But what every vehicle that is launched from this, the machine itself, the vehicle itself, whether it's a Falcon or whatever the rocket is, its mechanism, its computers on board has self-destruct. It has what's called telemetry data. It keeps track of where it is. And if it violates the restrictions, it will blow itself up. It will blow itself up. And they rely heavily on that. If it's manned, they rely on that. They won't let the people down. If the person inside, they man. If that fails, then the person on the ground. But for all manned, the machine has to blow itself up. But for example, when you have that shuttle, that and have that picture on board.
McCullough, President McCullough.
Yeah, so when the booster has separated, the booster is the issue, each piece of it has its own blow up. The booster, actually it was the booster that blew itself up, because it wasn't working right. It was carbon emissions. But on board the flight, on board the shuttle part itself, they were all alive, right? They weren't damaged. What hurt them was it fell back up. So they got an impact. But they did not get blown up. But the boosters, one of the boosters blew itself up, and then the other booster, which was going erratic, was blown up by the range. They blew that one up because again, they blow it up. They don't want it to go too close to civilians. And the reason they do that is for range safety, because if it's off track, if anything was to happen, the cloud or the chemicals that are in these clouds that come from these rockets are toxic, and you don't want them to blow over on the civilian side. So range safety is one of the reasons why they're so on the launch. The wings aren't right, because if something goes wrong, the clouds can be blown over the whole, and they can't have that. So all the decisions they make is because of houses on the So 3 miles is the closest everybody can reach where they can launch it. It's 3 miles. Just the sound itself, but even the sound, travels. I mean, my windows, I
Yeah.
can launches, and my windows rattle.
Mine too.
It takes a while for you to hear the sound, but you can see it because the sound is going.
Yeah.
So, it's pretty powerful stuff. But that's a graph. Graphing is everything in the real world. I don't know anything that's not graph. Even scientific data is graph because they want to see how something is changing over time. You have to graph in order to see any kind of trend. So graphing is really important. I know people don't like graphing, but in the real world, that's what you have to know how to do if you're going to get anything out of it. No one's going to look at a bunch of numbers and tell what's going on. The graph tells the story. By looking at it, you can see patterns. So a graph is very important. That being said, it's important that you understand how to graph and how to graph very easily, quickly. There's no reason your graphing should be a headache or should take a long time. It's very, very simple. To graph a line, you need minimum 2 points. That's it. To graph a line, you need 2 points. As long as you have 2 points, you've got a line. But the problem is if you only have 2 points and one of them is wrong, you'll never know it. That's why they want you to plot 3 points. So just because you make a mistake, chances of making a mistake on 2 of them is very slim versus 1. So if one of them doesn't line up, then they figure then you don't know which one is wrong, but you'll just redo it and check off 3. Or 2, you'll never know if you made a mistake. 3, you might be able to tell if you made a mistake, but not with 2. So, but there are 3 techniques. There's the point technique, where you just pick a point, pick an X, find a Y, pick another X, find a Y, pick another X, find a Y, plot the 3. That's too tedious. It's too much work. So we have other methods. The reason we have multiple methods is because, remember I mentioned, math is supposed to be easy for you, not hard to do. So we have 2 other methods, and those 2 methods are what I'm going to focus on. And one of them is called the intercept method. This is the intercept method, meaning that there's the 2 points that I want are the intercept points, x comma 0 and 0 comma 1. This is the y-intercept where it crosses the y-axis. That's the y-axis. This is the x-intercept where it crosses the x-axis. So if we have the 2 points that we are graphing or plotting are on the x-axis and the y-axis, here's the y-intercept, here's the x-intercept. If I connect those 2 dots, I've got my line. So this is called the intercept method. Where on the axis are these points? If the axes are easy to find because one of the components is always 0. It's the easiest point to find, because if one of them is 0, then just put 0 in for that letter, find the other letter. You can only find one letter at a time. If one of them is 0, it's easy to find the other letter. So this method is a very straightforward, easy-peasy method, because it's not stressful. The problem with this method, though, is that depending on the equation, it may not work all the time. For example, the formula that this method is used for, intercept method is used when x and y are on the same side of the equation, I'm just going to say now, relationship sentence. This can be a lesson later. So here's it, ax plus by equals c. X and y are on the same side of the relationship sentence. C, the other side of the equal sign, this number c, which I don't know what it is, but whatever it is, it can't be 0. If this is 0, then I cannot use this method. But your A and B, they both can't be 0, but one of them can be. Those are your special lines. A and B and C are elements of the real number. They are real numbers. X and Y are the variables. They are the variables. The first component of a point is always, I don't care what you call it W, or call it whatever you want, but the first component of a point represents the horizontal axis, graphing axis. So the first component always represents the horizontal. So here's my horizontal axis. Horizontal is this way, and that's my x. And the reason we use x, y, and z is because of the letters of the alphabet. Whereas in the D world, that's y, z. But in the real world, they don't use x, y, z. They'll use the letters that represent what they're doing. They'll do T for time, or the D for distance, whatever. They use the letters that represent what they're talking about. In the math world, we just use x, y, and z because it's arbitrary. But your horizontal axis is always the name of the first letter here. If that was a W, this would be a W. If that's a V, it would be a V. This is a T, that would be a T. Doesn't matter. It's not the letter. It's the position in the sequence of order. It's what's called an order pair. It's position that is divided in this pair as to which one is horizontal. The other one is Y. This is your vertical. And it doesn't matter how many letters you have. There's only one output, and you can have multiple inputs. But only one output. And your last one is always the output. You can have multiple inputs because, when you're looking at an equation, there can be a lot of factors. I mean, wind, temperature, whatever, altitude. You can have all kinds of variables that are impacting where the vehicle is. If you have a lot of winds, then it's going to be, depending on how strong the winds are, it's going to have an impact on where it's positioned. So your beginning letters you can have more than one. It just depends on however many you're allowing to impact the output. But you have input number 1, input number 2, input number 3, and then you have output. There's only one output. And your output is always your vertical. You only have one vertical. But you can have a lot of horizontals. This could be your x1, this could be your x2, your x3. So I can have, this could be, I can have guy's coming out here, and you got that guy, you can have another one coming out, you can have as many, this is your X1, your X2, you can have as many inputs as you want, but only one output. You follow what I'm trying to say?
Yes.
So it doesn't matter, how complex your sentence is, your math equation is, if your output is only one output number, multiple inputs. But to make it simple, with just a line graph, and to make it simple, we're only gonna have one input, one output. You start with that, you learn with that, and then you apply the same concept to multiple inputs. Because whatever works for one works for all of them. Your beginning is always your inputs, the last is your output, all the time.
Okay.
And that depends on the equation. When I have an equation like this, one input, one output, that's very simple. This is the simplest equation you can do, graphing. You have one input, one output. This is not an input or an output. That's not a variable. That's a constant. And these A, B, and C's are numbers. X and Y are numbers.
Gotta stop.
And the A and the B and the C, those are just customizing this equation. If you didn't have, if they were all one, this line would just go right through the order. Okay, they were all, you would just go right through. If you didn't have a C, if this was a zero, actually, it goes right through the order. If these were ones, it's a very simple equation. But we put letters, but you have to have a handle numbers. You have to know how to handle the numbers. You can't always do one, right? So if you say A times X plus B times Y equals C, you should be able to handle when it's not a one. Okay? But this is the equation for a line. This is the equation for a simple line with only one input. I can make this equation more complicated by having more x's. It would still be a line, but it just has more inputs. Just makes it more complicated linear. But this is the simplest linear that you have. And then we have two special case linears, and I'll show that in a second. But then another question should come. The number of letters tells you the dimension. You can look at it that way. This is a two-dimensional flat plane. If you have multiple letters, you can still, it's how you want to view it, just consider a variable a different dimension, but we don't always do that. We just say it's just an additional contributor to the output. You don't have to look at it as another dimension. Because when they show you where an object is when it's being launched, believe me, they've got like over 20 variables that are input into that equation. That equation is a complex equation, and one output. Okay, but so there's a lot of numbers that it's crunching, but it's only 1 point on the block. Even though there's a lot of variables that go into creating that wave equation. So this is a two-dimensional. I mean, this is 2D. Even if x is a multiple of x's, but it all solidifies to 1x, you can look at it that way. So this is 1x input, 1 output. Then the question should be, how do I know it's linear?
What I need my money.
How you know it's linear is if the powers, a linear equation or a linear relationship. I'm just going to use the word equation, but just think of equations, even if it's a less than or greater, it's the same. Linear equations have power 1 on all variables. If you have a power 1 on all your variables, it's linear. That's how you know it's linear, power 1. So I know before you can graph this thing that it's linear, because of the power 1. And you don't see power 1. So this is a linear equation. If the power is 2 on one of them, it doesn't matter which one. You can have both of them could be power 2 or one of them could be power 2. If the highest power on a variable is 2, then this is a parabola. A parabola, and parabolas look like this. Like this. It's not a line, it's a parabola. Has a curve to it. That's a power 2. Power 2, you got a curve. And majority of the equations that they use for launching are parabolas. Something goes into the parabola. So power 2 is the way they graphic when they model. They'll use a power 2. And then if you have a power 3, so the equation like this could be ax squared plus b1. See, power 2 is a parabola. If you have a power 3, so you have, let's say, ax cubed plus by equals c. If you have power 3, then it's called a cubic. And a cubic looks like a graph like this. It's like a snake. I call it a snake, but really what it is you take a parabola, cut it in half, and flip the other side. So if I take a parabola and I flip the other side, it looks like that. Not the cubic, but you can't really see that. That's called the cubic. It's cubic. Power 2 is a parabola, power 1 is a line. So I know just from the power on the variable what kind of graph. Are you okay with that part? And you've worked with them, you've seen parabolas before, right? And you've seen cubics before. Well, but it's very similar to this, but this one has to go that. Because when if x is negative, this is going to stay negative, so it comes down. If x is negative here, because it's power 2, it's always positive, so you never get negative power 2. But with power 3, you get negative, so that's why part of it is going down. Okay? So you got your cubic, your parabola, and then you've got your line. So we know this is the equation for a line. And when x and y is on the same side, this equation has a name, and it's called standard. The standard equation for a line. When x and y are on the same side. Standard. It's considered standard. And when you have a standard, the reason I have my phone on is because my daughter is at the hospital right now.
Oh.
Okay. She nearby? Yeah. So after class, I'm gonna have a okay. Nice. Alright, so, this is, are we okay so far? We're good? Okay. So standard, x and y on the same side, the line. Alright, the intercept method. X comma 0, 0 comma 1. If one of those numbers is 0, when you go to plot a point, we always use the first one, x is over here, but y is 0. Well, this horizontal line, y is 0 right here. We're already sitting where y is 0, so we stay put and we highlight the point. If I want to plot this point, x is 0. Well, where is x 0? X is 0 right here at the origin. X is 0, and then I go up or down depending on what y is, and if y is positive, I go up here, and because I now did both components, I highlight that point. So a 0, if one of them is 0, you're on the other axis. If y is 0, you're wherever x is, that's what you're on. You're going to stay put on this because y is 0. If x is 0, you're going to go to the origin, and then you're going to stay put on y, on the y-axis, because x is 0. So all the points on this y-axis, x is 0. 0 comma 1, 0 comma 2, 0, 1 is right here, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, negative 1, 0, negative 2. All the zeros are on the y-axis. Everybody clear on that?
Yes.
If you're on the x-axis, y is always 0. This is 1 comma 0, 2 comma 0, 3 comma 0, 4 comma 0, negative 1 comma 0. If you're on the x, y is 0. Otherwise, you can't be on this axis if y is not 0. Because y is 0 means you stay put on there. You don't go down to 0. You just do it. Is it clear on how the intercept points work?
Mm-hmm.
All right. This method, the intercept method, is a very easy way to graph. I'm just going to show you. There's no work that needs to be done. If the numbers are nice, if the numbers are not nice, then you do have to know how to divide and all that crap always. But if the numbers are nice, then it's easy. 2 2x plus 3, let me make these numbers nice. I'll make it nice. 3y equals 6. Because 2 and 3 goes into 6, so these numbers are nice, correct? All right, so I want to
Yeah.
find this point right here. I want to find x comma 0. Who's 0 in this, which letter are they telling you?
3y.
Huh? They're telling you that y is 0, correct? So I'm gonna, that means the y guy is gone. When you put a 0 here, he's gone. So all I need is the 2x equals 6. The y guy is gone. That's what that 0 means. The y is gone. He's not there. So 2x equals 6. That means x equals 3. So this is 3 comma 0. I can do that in the head. This guy's gone. This has to be a 3, 3, 0. On the intercept, this guy's gone. Which 3y equals 6? What does y have to be for 3y equals 6?
3.
2. 2 times 3 is 6.
Oh, yeah,
So
2.
that means 0, 2. Those are my 2 points. I plot them 1, 2, 3. 1, 2. That's how easy it is. That's how easy it is. Following? The intercept method is just find the intercept. If the numbers are nice, you can easily do it. If the numbers are not. If they're not nice, it can take a little bit, but let's say I have negative 5x minus 2y equals 10. When you're finding your x comma 0, the y is gone. So when you're finding the x comma 0, all you need is the negative 5x equals 10. Anything dealing with the y guy is out. You don't even bother with it. So what does x have to be to give you a positive 10? We have a negative 5 in front. X is equal to negative 2. So one of the points is negative 2. That's your x-intercept. Now, for the other point, 0y, the x guy is out, or I need everything dealing with y. So negative 2y equals 10. What does y have to be to give you a 10?
Negative 5.
Negative 5. So 0, negative 5. This is the y guy. That's it. That's it. And then you plot the 2 points, connect them, you're done. I mean, is that like basic?
No.
I mean, you're solving one letter at a time. That's it. One letter at a time. The other letter's gone. He's a 0. He's out. You're solving one letter at a time. And because you have to know which point you're dealing with and where that number goes, which you just found. When you have the x-intercept and you solve for x, y is 0, so that number has to go in this slot. That's a mistake who makes them put those numbers in the right slot. Or one person takes this number, they put it together. You don't put these two numbers together. These are the only 2 points you're finding are these. That's it. You don't put these two together. This negative 2 is the x. This negative 5 is the y. On these points, on the intercept points. That's it. These are your 2 points, and the 2 points make a line. Everybody clear how easy? How easy? Let's do another one. What if you have negative 4x plus 8y equals 16? If y is 0, because I want to find this point, y is 0, what equation am I going to use? Negative 4x and the 16, that's it. This guy's out. So what does x have to be to give me a positive 16?
Negative 4.
Yep. You can do it in your head. That's point 1. How do you get point 2? This guy's out. What does y have to be to give you a 16?
2.
That's your 2 points. Are we clear on how to do it? Now, did you have that in basic?
No.
We went straight to slow. Yeah. Well, we're gonna get to slow.
Oh, yeah, we did.
Yeah, but we didn't, like, we went straight to slow, there was no, like,
There was none.
graphing.
Well, we're gonna get to slow too, but we have to know how to graph it. I'm gonna graph this way. Should be a different way to graph when you need to slow. But, no, but graphing is an objective of basic math.
Yeah, we did go straight to slow. It was just like,
Well, he was probably running out of time, I don't know.
Here you
But
go.
He needs to follow the syllabus. All right, so graphing is this is the intercept method. Intercept, because the name is finding the intercept. And it's the name intercept, and these are the intercepts. One of them will be 0, so we can only solve one letter at a time in it. It's a very nice method. Now, the slip of a line. Let me explain to you what a slip of a line is. Slip of a line line is not a point. A slope is a fraction. A slope is a rate. It's a rate change. A slope is not a point. Slope of a line is the algebraic inclination of the line. It's the algebraic, not the geometric. The degree, 30 degrees, that would be geometric. This is algebra. This is algebraic inclination of the line, if you want to look at it from a technical perspective. Algebraic. But I don't look at it from a technical, I look at it from a practical view, from a practical view. The slope is a ratio of changes, of two changes in the variable, in the two variables. Two changes in the two variables. It is a ratio of the changes in the two variables. Slope, which we say is m, because I guess s was taken. Slope, which equals m, is equal to a ratio. Ratio means fraction. Ratio means fraction. A over b, that's what ratio means, of two changes. A change is the delta symbol. Delta, the triangle symbol means delta, which means change, like the delta of a river, when the river changes in direction. So a delta is the Greek letter for that symbol that looks like a triangle.
Okay.
Changes, which means the difference. Change can be difference. It's a change is the difference in two variables. So we have the change in y, and we have the change in x. Two variables. There are two changes. In the x, change in y. There are two changes.
Okay, I'm back. I'm gonna do, because I can't stop yawning. It's getting bad. I try to just get through it. Yeah, I'm gonna do hot chocolate. Yeah. It is terrible. I'm just like, oh my gosh. I know. Let's see. Oh no. Okay, let's do this again. Insert pod. Hot brew. 10 ounces. I just got hot chocolate. $2.50. Thank you. I should have got some candy, but I have too much sugar. you too.
Look, it's not just for a little line, it's sort of for a lot of things, it's your speed. Let's say you are pressing, you're changing your speed, you're accelerating. Change from the speed prior to your new speed with respect to the time that is acceleration, and that's also. So these are your slopes, velocity, acceleration, your snap, crackle, pop. You do that serial snap, crackle, pop? It actually came from physics. Those names are physics terms, they are not, you look them up, snap, crackle, pop are the fourth derivative, fifth derivative, sixth derivative, first derivative.
Hmm.
So the sound, they try to get the names to match the sound, like an acceleration is a jerk, like, you know, your car might jerk a little bit, that's when you're trying to accelerate too fast, and it gets that jerk, that's because you just changed your acceleration. Now it's got that jerk, the jerk happens. The difference of two jerks, in the ratio of two jerks, is a snap. So if you snap something, that sound, that snap sound, that's classified as the difference of two jerks.
Hmm.
So think about it, you're jerking something, jerking, you get, and the way you change in jerk makes a snap sound. Crackle, crackle, pop, snap, crackle, pop, those words are words that change. And you never consider it to be that.
Mm-mm.
I'm not sure what a quantum physics theory would look like.
Well, you need probability predictions, so sometimes you get it, sometimes you don't.
Well,
Sometimes the theory will come out, sometimes the theory won't come out.
Yeah. You know, you're looking at it
But
and,
quantum physics is probability, and probability is somewhat unpredictable, not 100% unpredictable, but that's what makes quantum physics very challenging.
and it also almost just when you're looking at it.
Well, it could be something organic, it depends on probability, okay? But that being said, a slope is a ratio of two changes in two variables, and when you make a fraction out of it, and since we're dealing with x and y instead of distance and time, we're just going to use arbitrary. This is distance in time, the change in distance with respect to time is equal to speed. That's the speed. They don't call it a slope, they call it speed. But definition of a slope, because we're in a math class, is a slope. But when you use it in the real world, we call it something else. We call it what it's trying to give to us. In the math class, it's generic. That's why math is like, you're learning a math class, but what good is it doing? It's doing no good, because when you go to physics, you don't even make the connection that a slope is speed. When you even had a physics teacher explain slope, did he ever mention the word speed?
Mm-mm.
This is his field. I don't even know if he knows that it's a slope, to be honest with you.
I think he kept it like pretty basic.
I'm keeping it basic.
No,
You
no.
have to relate.
Yeah, so you could
got to
understand.
relate.
I'm not saying you're not, I'm just saying like.
I mean, keeping it, if I just left it like this and didn't talk to you about this, how would you wouldn't understand? Because you didn't know. When I said ratio of two changes, did you ever think about speed? Did you think
No.
about something in the real world that has a
No.
fraction of two changes? How about the heart rate? You're in the medical profession. What is heart rate? What's the units on heart rate?
Beats per minute.
Oh, wow. So what is heart rate? A slope. You see what I'm getting at? You learn stuff in math, but you have no way, even when you go to your field and you're learning speed, you're doing physics class, you're in your medical class, you learn heart rate. Did you ever make the connection? Oh my gosh, this is a slope. I learned this in my algebra class. This is a slope. No, you didn't, because
No.
once you learn this, you forget it when you go back again. Because this doesn't have, you made no connection to this. There's nothing that you connected this to anything that you do in the real world. So why is it, it's useless to you because you made no connection to this. You don't see how it's used in the real world, so you make no connection because you don't need to. Because you obviously can live your life without knowing that those things are slow. You don't need to know that to pay your bills. You're working in this field, this is your job. So, that's the problem with math. The problem problem with learning in a math class is that you learn this material, you don't even know why you're learning it, it's like you can't relate to it because you don't even know how it applies in the real world. So it's useless information. I didn't even get an A in that class because I need an A for GPA. And that's really all you care about. And I understand that. And it's sad that you know, it's sad that that's the way it is. But, you know, like when you're in your field and you're learning heart rate stuff, you'll be excited because this is your field. And then but the teachers in there, nobody in the real world tells you, hey, you know when you're in algebra, you learned the slope, well, guess what? But did any teacher ever say, hey,
No,
here, this is the slope?
they don't.
And I guarantee you, if you get one, it'll be a monster. Because a lot of teachers don't know, or they forgot themselves, or they never made the connection. Or they don't think the connection is important. That is the sad part, they think the connection is important. If they don't think the connection is important, then they won't tell you. Because they figure, what difference does it make? But if they told you, it would say, hey, you know what? You really didn't waste your time in that math class. Because you learned what a slope was. Now, guess what? We're putting it into action. Now you're going to see it in action. If they had made it seem like the math class wasn't a total waste of your time, then maybe we would have felt better taking that math class. That's what the only good thing about it. But, you know, they don't use the same letters, X and Y. They use DT. Because this is the real world. Okay. Right? The change, this is your change in distance and over the change in time. So if you're going 55 miles per hour, what is that slope telling you? It's telling you that if I continue at this, if I keep this pressure on the pedal, I will travel 55 miles from where I am now, mile marker, let's say I'm at 100, get to mile marker 155, I should get to mile marker 155 within an hour. Or 5
Yeah.
hours. That's what your speed is telling you. It's telling you where you're going to be when you make, so when I plot a point, and my slope is going to tell me where I'm going to be next. So let's say I'm over here, I'm at 2, 1, I'm here, that's where I am. But my slope is 5 over 2. So what my slope is telling me, that if I go 2 units this way, 1, 2, 2 units this way, I will be 5, an output, a distance of 5 from where I am now. 1, 2, 3, 4, 5. I will be here. I will be 2 this way, 5 up. I'm going to be here. So that slope of 5 up, 2 left is going to put me in a new location. That's what my slope is telling me. It's telling me where I'm going to be 2 minutes from now. I'm going to be over here. Another 2 minutes, I'm going to be over here. Another 2 minutes, I'm going to be over here. A slope is telling you where you're going to be. If as long as that slope is consistent, you don't mess around with the speed. And say where you're going to be if you can't maintain that 55 or that 5 per 2, that 5 miles per 2 seconds or whatever I'm doing, whatever the units are. It's going to give me a line. If I change it. If I change the slope, well, then I'm going to be at a different location. I'm not going to be here, I'll be even further, you know, it depends on the distance that what I've done. You've been following what a slope gives you directions as to where you're going to be. That being said, then, and I already said the slope is the change, and we know change is difference, then the formula for a slope is automatic. How do you find the difference between two things? What do you do to find the difference between two things?
Subtract.
So if y is my output or my distance, then my second y minus my first y, that's my change in y. Then my change in x, my change, so by definition of a slope, it has to be the change, and that's where the change comes in, because the difference is your delta, is the change, and change is difference. So your definition for a slope is your change in your y over your change in your x. But then people go, well, how can we put the x at the bottom? When you put the x at the bottom, remember, your output is always the last letter in a point, your output. And your input is time is usually not the output. Time is, in the real world, is never output, because we know time. Time never ends, it never stops, and it's continuous. So that's never an output, that's always an input. So your input has to be the bottom number, because it's miles per hour. So time has to be in the denominator, hence why the x is in the denominator, because x is usually time in your work. Do you follow me? And your output is always the top, which is the result of what you're doing over that time. That's the top, and that's the y. The y is the output, your input is the bottom, so it's input over output over input. That's the reason why x has to be at the bottom, because your input is at the bottom, your output at the top. So y is the output for your input, input is usually time. So this is the formula for a slope. And this formula did not come first. The concept came first, and then the formula came after. Okay? Formulas are created after you know what you're doing. You create a formula for it. So the formula did not come first. The concept of applying these changes came first. Okay? So a ratio of change. Now, is everybody okay with the definition of a slope?
Yes.
It's the ratio of two changes. It's not a point. But we can use these changes to help us to get a point. Help us get a point. It is not a point. It's going to help us because it's changes. If I'm at mile marker 100 and I add 50, and I'm going 55 miles per hour, and I add 55 to my 100, where am I now? What mile marker am I going to be at?
150.
155. Right, and then the bottom number is the change in x is going to tell me how much time it's going to take me to get there. But our units for distance is per hour. So 1 hour, I will be at mile marker 155. Because that's standard is 1 hour. Our time is always 1 hour. So I'm going to punch that on. Everybody okay with that?
Yes.
All right, so I add the and if I was at mile marker 100 at 1 p.m., what time is it going to be when I'm at mile marker 155, if I go 55 miles per hour?
2 o'clock.
2 o'clock. So I add my slope numbers, I add these changes to my current position to get my new position. Do you follow me?
Yes.
And then I can add it again to my new position to get another position. I can keep adding those changes to the previous position to get a new position. Everybody following what I'm doing?
Yes.
All right, now that you
Fine.
understand what I'm doing, I'm going to show you how to graph using this method. All right, you're going to graph using the method the same way I would figure out what mile marker I'm going to be when I'm on the expression. I'm going to call my friend and say, hey, in 1 hour I'm going to be at mile marker 155, okay?
Yeah.
Making sure I go 55 miles an hour. I'll be there waiting for me. You see, if I want to
Yes.
tell somebody where I'm going to be an hour from now, to wait for me, then I would do exactly what I'm doing to tell them to do what I'm going to do to get a graph. So let me give you the
I'm at
equation
marker
that this is used. It's not used when you have x and y in the same section. Not used for that. We use a new method. This is method number 2. And this method name is called the slope, because slope is information I'm going to get. Intercept. It's called the slope-intercept method. So that means this method gives me 2 pieces of information. It gives me m, and it gives me 0, 1. It actually gives me the y-intercept. So this method, I need 2 pieces of information. I need a starting location of where I'm going to start, where I am currently. And then I'm going to use the changes. I'm going to add the changes to my starting location to get me where I'm going to end up. Are you following what I'm going to do? Because my slope are changes, are they not? If I add those changes to my current position, I get my new position. Just like I did in the example with the car. So I'll show you how to do it. So this is the name, slope-intercept method. And it turns out that when y is alone in a math equation, it turns out that the m and the y-intercept is given to you. The slope m and 0, comma y, which we say 0, comma b, it's the same, that b, is given to you. It's given to you. You know exactly what it is. Let me show you. If I said y is equal to 5 over 2x plus plus 4. When y is solo, in this math equation, the slope m and the 0 y, which we say 0 b, is when x is 0, y equals b. See, if x is 0, what is y going to be equal to if x is 0? Y is what? If x is 0, this guy is gone. What is
Oh,
y gonna be?
4.
4. So this number is your y when x is 0. Your y is the b. Following when x is 0, only when x is 0. So what happens is the m is the guy in front of the x, and your b is the guy after the x. So your b is the guy after the x, and your m is the guy. So your slope and your y-intercept is b. This is always the case when y is solo. When y is solo, these two pieces of information are given to you. You don't have to hunt for them. You don't have to work for them. They're given to you. That's like a gift.
Yeah.
Because now with those two pieces of information, I apply my concept that I just gave you, the concept of the car thing, I can grab this tomorrow. And I'll show you how it's done. Alright, so here it goes. You ready? How simple, this is even simpler than that. You ready?
Yeah.
The first thing, there's two different pieces of information that I know, correct? What do I know when I do this? I know that m, which is my change in y over my change in x, is 5 over 2. So which one of these numbers is the change in y? The top. Which one is the change in x? The bottom. Because change in y over the change in x. Which one? They match up with these numbers. So who's the change in x? What number is that? What is the change in y? So I know my changes. I know my changes from this direction. I know my changes in that direction. Time, distance, whatever you want to do, direction or whether you want to. I just know what these changes are, correct?
Mm-hmm.
Okay. I'm going to apply them to what we call the y-intercept point. Your y-intercept point is the b, 0, comma b. When x is 0, what is y?
4.
So 0, comma 4, that's your y-intercept, is that correct? So you know that, right? Because you just say, okay, these two pieces of information is given to you, the 0y, is 0y then 0b, so that b is the point out of it. And then I'm going to take these numbers right here. You see these numbers right here?
Mm-hmm.
Let me show you what I'm going to do. Use arrows. I'm going to take that 5, and I'm going to take that 5, and I'm going to add him to the 4. Okay, that's my y. That's the change. This is the change in y. That's my y. I'm going to add that 5 to my 4. That's the change. That's what I'm going to do. That's the difference I'm going to make in this amount of time. I'm going to take that 2, add it to my 0. That's it. You just take these changes, you add them to your current location. This is my current location.
Okay.
These are the changes I'm going to do. I take the changes, I add them. Now, what's your new point?
2.
2 and 9.
Because you're adding 5 to 4. Here's my second point.
So is this the same as y2 minus y1 over x2 minus
Well,
x1?
the change, I already told you when you have this equation, you know the change. I don't know the individual points. I just know the change. When you have that method, you don't have to have the two individual points. If you have the equation, you don't need the two individual x, y. You don't need the two y's.
Right.
This is the formula for a slope, but when I grab it from here, I'm already told what those numbers are. You already know what that change in y is. Why do you need the two y's? I'm telling you, the change is fine.
Okay.
That's what I'm saying. You don't need the 2 points. You're already telling me what it is. If I didn't tell you what it was, then you need the 2 points,
Okay.
which we are going to do in some examples.
That's later though. This is different.
This is just graphing. This
Okay.
is graphing. Okay. Graphing using these two equations. The only two equations you got. You got the standard.
This is new.
Well, this should
Right?
not
We
be
didn't
new.
do
And I'm
this.
going to talk to the best about that. This should not be new. This
We
should
didn't do
not be new.
this.
If this is new, there's a problem. We've got an issue. And and I'm gonna fix that issue. Something's gonna have to be done, because this is not right.
We didn't do this, right?
Right. So, this is on your final exam. Did you guys see this question on the final exam, graphing? Have any graphing at all on the final exam in that class?
Mhm.
It's more like solving slope, and we're plugging
And
the
finding
numbers
y.
into the equation.
Yeah, that was it.
What do you mean?
Y2 minus Y1.
Yeah,
so
you're
they'll give you
calculating
zero.
slope, but that's not graphing.
That's
Talk
all we
about
did.
graphing,
We have
whenever you
not,
use
we did
graphing.
not have, we did have to graph some numbers, but not
But what do you mean by
basic
graph?
like
Talk about plot a number?
Plot a number.
number.
Yes, that was
Whatever-
it.
Did you have to connect them with yours and make a line?
Yes,
this.
Well, then that's called graphing.
Oh.
So you did do graphing.
yes.
Correct.
Yeah.
So then he showed you how to graph. So he did do it then.
Differently.
Differently. I don't remember this. This
Like,
is
he
new
didn't
for me.
teach us a whole equation, he literally showed us on Pearson, and he was like, here's how you connect a dot, here's how you connect a dot, and that's it.
Yeah, because I like homework, I feel like
Do we have to graph a line? I think I just skipped all that. I didn't even fuss with it. I was just like, I'll just skip that wrong then.
I just think towards the end, maybe you didn't have time.
That's literally why I got a PNS class. He's like, what you graph? What you
Try, I'm
graph
gonna
to?
do it again, please pay attention very closely. This is the first time you're seeing this, please pay close attention. This is not hard, let's not make this hard, okay? Everybody ready?
Yes.
Y is equal to negative 2x plus 4. And keep the numbers nice. Okay? Since when y is alone, please write this part down before you see it. When y is alone, the name of this equation is slope-intercept form. If you use the slope-intercept method. You have to know which method goes with what kind of equation. This is called the slope-intercept method for the slope-intercept form. When y equals mx plus b is your slope, because the slope is given to you, and your intercept is given
It's
to you.
called.
The intercept, and this is form. This is called the slope-intercept form. Slope-intercept form. Everybody see the difference? Right. This is called standard. These numbers in front here are not they're not y-intercepts. I can find the x and y-intercept with standard, but none of these numbers are telling me exactly what they are. I have to find them. Over here, I don't have to find them. This equation is telling me exactly what those two things are. That's why this is awesome. This is awesome to have y alone. The information is being given, it's being given to you. You just have to read it properly. So underneath here, you write the form, mx plus b. Just write it underneath it, and then you graph. M is everything in front of the x, including the sign. Your b is everything after the x, including the sign. Now you write that down. M equals negative 2. B equals positive 4. You just grab it. You didn't have to calculate this. It's given to you. Now is where your work comes in. Now here you have to know how to utilize this numbers to graph the equation. Now you have to kick in. Following? It did its work. Now you got to take it from here. So the first thing you do is you make a point from this form. This is the y-intercept point. It's the y value for the intercept point, so you have to put a 0 in front of it, because y-intercept, the x has to be 0 to be called the y-intercept. So you got to put a 0 in front. Now it becomes the y-intercept point. This was the value, now it becomes the point. So you put a 0 in front of it. And you have to do that. It won't do that for you. Okay? So be clear on what I just did. Clear on what I just did. Okay. Now you have to convert this slope, if it's not already a fraction, because the definition of a slope are the changes of the two variables. That's what you did apparently in this class. You had 2 points, and you took the x's, and you took the 2 y's, and you did the subtraction, made a fraction out of it. You didn't know why you were doing that, but you just did it. And you didn't even ask why. but that's okay, you just did what you had to do, and that was it. Right? Those are the changes, those are the change in the Y, that's from your mile marker 100 to mile marker 155 to mile marker 100. That's the change that I did with my speed, 55 miles in 1 hour. This should be 55 miles apart, these numbers should be 55 miles apart. Okay. How much time did it take you to go those 55? Well, it took me 1 hour, but if I have my two X's, I'll subtract them. And in this problem, it did, this is not my car thing, so whatever this number is, that's the difference in my two X's. Changes, the difference in there. Is it pretty clear what that number means, what that slope is telling you? So this stuff of -2 is telling me -2/1. You have to have two numbers. If you don't have two numbers, you're not going to have two changes. So if you have a whole number, you got to put it over 1. That's your 1 hour, right? You never show denominator. That's why your speed doesn't have two numbers, because it doesn't show you a denominator of 1. That's why it says 55. Because it's 1 hour, it doesn't show you a denominator of 1 hour. You just know it's per hour. You following?
Mm-hmm.
But when we go to use it, we have to still show that 1. You got to add that 1, right? So I got to show you the 1. I got to add the hour. Is it clear as to why I got to put it over 1? Right. Now, the top number is your change in the Y. Top is always change in Y, always change in distance or position. Your bottom is always your change in X or change in time. X is always time in the world. You have to remember X as time, remember X as time in the real world. It's always the bottom. Time is the one thing that will never go zero. You're not moving because you're at a stoplight, but what is changing? Time. So you're sitting there, but you're not moving, so your distance is 0, hence your speed is 0. Because you're at a stoplight, okay? The time is still going on. Because you don't like zeros in the denominator. You can't have zeros in the denominator. That's why the X has to be 5, okay? All right, these changes, if I add them to this position, is going to give me my future position, because that's my speed. Apparently I'm going backwards. I'm driving backwards with a negative. It's velocity. Actually, speed with the sign is velocity. So I'm falling. I'm driving backwards. 2 miles per hour, or 2 miles per second. Whatever you want to put 1 in. So I'm going backwards to, that's what I'm doing, okay? And that's a negative number. But whatever that is, this number, all of this, I'm going to add it to him. All of this gets added to him. I'm adding these changes to that location. I'm going to get a new location. Can that be any simpler? I don't know.
No, but I'm just trying to figure out, how did we get 0 for... We have 0 and 4. So I understand how we got the 4, but how do we get the 0?
Well, then you don't understand how that.
No.
All right, where is the 4 here?
The 4 is on the end. That
Okay,
is...
And this position is Y. So how is Y going to equal 4 if I have a negative 2x here? What does X have to be so that this is not interfering with Y equaling 4?
0.
That's where the 0 comes from.
Okay.
Right, you put a 0 in here, which is what we did here, did we not? We put
Right,
a 0
yes.
in, and then that gets rid of that letter.
Got it. Yes.
It's the same concept here. If I put a
Okay.
0 here, that guy's gone. What does Y equal?
4.
That's the reason why this has to be 0, otherwise Y is not going to be 4.
Got
If
it.
X is not 0, Y will not be 4. You following?
Yes.
Right. Please pay close attention. Please pay close attention. But focus 100% if you can. Okay? This -2 is your change in the Y, so that change is going to get added. This 1 is my change in the X, so that's going to get added. And when you add 1 to 0, what's your number? 4. And when you add -2 to 4, what's your number?
Negative. No. 2. Positive 2.
Yeah. Where's the equation? Okay? 4 minus 2 is 2. So we're good?
Yes.
All right. So 1 comma 2. And because I went backwards, right? So it doesn't matter whether it's slope, the slope is going to go down. So slope, we have a negative slope, we actually going down. Like the Y is going down, but my X is going out. My X is increasing, but my Y is increasing. So my slope is going to go down. When your slope is negative, it's going to go down. If your slope is positive, the line's going up. Okay. All right, so here's my new location. So do I have 2 points now? Do I have 2 points?
Yes.
What are my 2 points? 0, 4, 1, 2. And all you need is 2 points for a line, right? So let's go ahead and plot them and see what my path is if I can maintain this -2. 0, 4, 1, 2, 3, 4, and then 1, 1, 2. So here's my line going down because it's a negative slope. So if it's negative, the line's going down. It'll keep going out, but the line's going down. But the x is positive, so the x is going like this, it's just a y. All right, let's try one more. Let's try because the more you do, the easier they become. Just let's make the numbers like this is x minus 2. Alright, first thing we're going to do is underneath, just say mx plus b. Always write mx plus b underneath. Exactly, match it up. So you know who you're grabbing, okay? So what does m equal? And what does b equal? Is m equal? It's imaginary 1. You don't see it, but it's there, okay? So imaginary 1. And then you have to make a fraction out of that 1, so you're just going to put 1 over 1. Make a fraction out of it, so you just put 1 over 1, okay? If it's not a fraction, you make a fraction out of it, just put it over 1. Okay. Now, what does your b equal? -2, and then what do we have to make out of the b? A point. So what's the first part of the point? Always 0. 0, -2. That's it. You gotta remember that. Okay, if you didn't remember it, write it down so you know the process. Because the only time y is going to be this is when x is long. X has to be 0 in order for y to be x. That's how you can remember it, I'm not sure. Okay? Now, what are we going to do to these changes? This is your change in y, that's your change in x. What are we going to do to these changes? You're going to add them to this position. So if I add a 1 to a -2 and I add a 1 to the 0, I get 1 comma negative. Are we okay with that? Now you have 2 points, the new one plus the intersect one, the initial one. The initial one times 0. You say initial one times 0. This is your starting. And then this is your new one with the change. With the change is added. And if you just plot those 2 points, 0, -2, 0 here, and then -2 here, there's the y-answer, so that's where I started. But below sea level somewhere, because negative means you're below the ground, 0 is at sea level, positive is above the ground. And then 1, -1, 1 and then -1. So I'm going up, and go to the other side. See how to do it? Do you guys remember graphing being that just simple?
I don't think we did that.
Just keep it simple. Can you handle it? It's not hard.
It's not
To
hard.
graph. You need information, but you gotta know which method you got and which information to use. That's why you have to have a name. This is called slope intercept, and I'm gonna use slope intercept method, and I'm gonna use my standard, and I'm gonna use my metric. No slope. I didn't use slope here at all. Just use 2 points. I only use slope when I have y solo. When you have y solo, that number is a slope. That's what it's useful. So that's why that is kind of slope. The slope is given to you. You don't need 2 points to calculate. If you were going to calculate a slope for this one, you have to use the formula because it doesn't give it to you. But this one, they give you the slope. You don't need the formula. It's beautiful, isn't it? How do you feel about the graph?
Good.
Feel a little bit better? You understand that slope is a ratio of 2 changes, so the formula makes sense with the differences, then you can change. Right? The slope is giving you the inclination, so now what I'm going to do is just give you the special lines. Alright, so your special lines, when you have a line, there's only 4 types of lines it can be. It can be a negative slope, if your line is going downward and pushing out, but y is going down as x goes forward. That's a negative slope. If your line as x goes forward is going up, that's and it's positive. I know it's positive. I don't know exactly what it is, but I know it's positive. If you have a line that is going straight up and down, this is called a vertical line, straight up and down, straight up, straight down. It's called a vertical line. And vertical lines have no slope. And no slope does not mean 0. It means m is undefined.
Okay.
M is undefined. It means you can't calculate it. Because if you take 2 points off of this line, you're going to get 0 on the bottom. So let's say this point over here is 5, comma 10. And let's say this point is 5, comma 6. Because in order to be a vertical line, your x has to be the same. I just went up 10 versus up 6. In order to be on this vertical line, your x has to be identical. Otherwise, you can't have a vertical line. Up and down line, the x has to be the same. Does it make sense? Right. Now, if I calculate my m with these 2 points, okay, here you go. This is what you were doing in basic. You were calculating m on 2 points, okay?
Yes.
Your 2 points, 5, comma 10, 5, comma 6.
Yes.
So you're 10 minus 6 over 5 minus 5. What's 5 minus 5? Hey, you're not allowed to have 0 on the bottom, hence the name undefined. So when your x's are the same, it's undefined. So if you know your x is the same, why even bother going through all this formula? You automatically know the x is going to be 0 on the bottom, undefined. It's a vertical line. Now, the beautiful thing about a vertical line is you're only going to have one letter. That's how you know it's a vertical line. Because these are special lines. You can't use any of this technique. They will not work. So you just have to know. So on a vertical line, what's going to happen is you're going to have x equals some number. The y will be missing. Y will be missing. If y is missing, you've got a vertical line. That's how you know. Okay? You're going to know because you have a vertical line. Okay? All right? Come on. All right. Are we okay?
Yes.
All right with all of this? Okay, now, the other special line is a horizontal. And how I remember which one's which, because I had a hard time remembering which one's which, because you couldn't memorize it. When your heartbeat goes to 0, when your heartbeat is 0, what kind of line do you say?
A flat line.
Flat line. Flat line is a horizontal line. M equals 0. Remember M, the slip is your heartbeat?
Yes.
Heart rate? Well, if heart rate is 0, 0 beats per minute, the top is 0, but not the bottom. So 0 is okay. This is 0 per minute, right? So it's 0. That's called a flat line. And a flat line is also a horizontal line. It's called horizontal line. And how do you know you have a horizontal line? Because x is going to be missing. You're just going to have your y. So it's going to be y equals a number. X will be missing. That's how you know you have these special lines. A flat line, X will be missing, and it's so a vertical line, y is missing.
If I pull it, it won't rip.
That would be, and then if you want to, if you're gonna graph this, you have to go decimal, in order to do it, but it's gonna be, 9 goes into 20, whose is gonna be 0.2, so it's very tiny, it's very close to, 0.2. That, everybody all right with that? And there might be something different, if you don't wanna graph these, then I'll find the slope, and then maybe I'll use that, I'll use the slope. Alright, so that's my x-intercept, everybody right with that? And now for the y-intercept is gonna be 0, x, so all we need is negative 7y equals 2. And then we solve for y, so that's gonna be negative 2 over 7, so this is 0, negative 2 over 7, so, and that's again a very tiny number, 7 goes into 20, close to, almost,
That's the one she's doing.
it's about 0.3, again, about 0.3. So they're very tiny numbers, but these are your intercepts. That's why I not to graph it at the end of the period. But we can still find them, we can still do the work and find them. Alright, so this right here is the y-intercept, is that what I got for the y-intercept? Okay, so we didn't into that part. Now the question comes up is we have to go ahead and find the slope. And you have two ways you can find the slope, okay? You have two ways to find the slope. To find the slope, you can either use the formula m equals y second over y1 over minus y1 over x2 minus, so you can use that, but I would not. I would not use that. What I would use instead is change the form. Change standard to y solo. Change the form from standard where x minus x sine to y solo. So we have 9x minus 7y equals y1. Because if you want to, if you're going to do the 2 points, you got to find 2 points. If you use these 2 points, I've got to subtract fractions. You want to subtract fractions?
No.
So this is why you make a choice. Do I want to use the formula and have to deal with subtracting fractions? Or can I change the form of this line to be this form where y is solo, and then the whatever number I get in the front, that's my slope. So you got 2 choices. Whichever one you want to use is your choice. But the reason for this question is to let you be aware of it. Okay? So if we change the standard to y alone, then this is what you do. Transpose the 9x. Because I want the y alone. I'm going to keep the y over here. I'm going to move my x. I'm going to move your x. Are you following me?
Mm-hmm.
So we have negative 7y equals negative 9x plus 2. So I just took that on x and I put it in front to try to match this form.
Okay.
X in front. Are you following what I did?
Yes.
All right, now what do you have to do to everybody to get y alone? Divide by who?
7.
No,
Negative
so
7.
I'm going to divide by negative 7. I'm going to do it to everybody. That cancels, so y is not, and what happens when you have 2 negatives?
Positive.
So that's just 9 over 7x, and then you have 1 negative, that's going to make the whole fraction negative, and you just say 2 seconds.
Okay.
I'm not going to change that in the decimal. So we have 9 over 7x minus 2 sevenths. Y is alone. So which one of these numbers is the slope? Which one of the numbers is the slope?
9 over 7.
Yeah, that's the first one is the slope. So that means that's the slope. That's how you know. So I'm thinking there's 2 ways for you to find the slope. Use this formula or change the form. I changed it.
Oh, yeah,
Not
change the
easier
form.
than to have to do the subtractions with 2 in effect.
Yeah, that's
Now,
easier.
if the numbers were nice, little whole numbers, I would use formula. But it's up to you. But the purpose of this question is to let you know that you got 2 choices. You wouldn't have known that otherwise. Are you following me?
Mm-hmm.
So this is mx plus b. So your m is equal to 9 sevenths. Are we okay with that answer to that question?
Yes.
And if these numbers were nice and I was to plot these numbers, I mean 2 9s, that's real close. That's real close to the origin here, to the origin, and then you have 0, negative, that's real close, these are really tiny, tiny numbers over here. So, this is my line is, okay, so it's real close, my line, very graphing, those points are really tiny, but, so. Okay, how do you feel about this question? Good. Okay, number 9, Chantal, number 9.
Find the slope of the straight line that passes through the curve.
Okay, so you have a pair of points. And what's the point? -6, okay. -7. Okay, now, notice what's the same. Notice who's the same. Who's the same?
-4.
The -4, that's your x, right?
Yes.
Your x is the same. So if I was to plot these 2 points, I go -4 on the x, and then I go down -6, and then -4 down -7. So it's a vertical line. When x is the same, it's a vertical line. And we know when you have a vertical line, it's a vertical line because x is matched. The x is matched in vertical line. You have a vertical line, m equals undefined. There is no calculation. Unless you want to do the math, but you should know it's a vertical line and m is undefined. But if you did the formula, you change your y, -7 minus 6, and -4 minus 4. So you get -7 plus 6, you get -4 plus 4, you get a 0 down here.
Right.
And you cannot allow. That's why you have undefined. It's not allowed. Right? So either you just do the math and realize not allowed, or you just know you got to the same, it's undefined. Automatic. And if the y is the same, you get a flat line, 0. But if y is the same, it's a 0. X is the same, it's undefined. Those are real easy to just think about what the line is that they're describing. Think of the line that they're describing, vertical or horizontal. Okay, any questions on this one? Good. All right, okay, this is first one.
And then, oh, you said it.
Oh. What was
A.
it? A?
Yeah.
Yeah, okay. Is it A, L? How do you pronounce it?
And then,
Annette, okay, go ahead. Number 3? No, number 7. Going back.
Eight.
number 8.
Oh, number 8, okay.
Okay. Find the slope of the straight line that passes through the following pair of points. 5, 1,
5, 1,
and 7, 7.
and 7, 6?
7.
7, 7?
Yeah.
Now, they want the equation of the line, correct?
Find the slope of the, yeah.
Oh, just the
straight
slope
line.
or what?
Find the slope of the straight line that passes through the following pair of points.
Oh, they just want the slope, no
Yeah.
graphing, no equation or anything like that, just the slope, okay, so in this case, we need the formula, the change in y and the change in x, okay? So we have the second y minus the first y, the second x minus the first x, so the second y is 7 minus the first y, which is 1, the second x is 7 as well, minus the first x, which is 5, so that's 6/2, comma 3. Are we okay with that one?
Yes.
It's pretty easy. That's you, because you did that in basic.
Yes.
You know how to do that. Okay. Number 7?
Graph the equation x equals -3.
Okay. X equals -3. Well, x equals -3, this is your special line. There is no method to use. You just have to know which one this is. This is
Oh, yeah, that's
x
easy,
equals
easy.
y is missing, correct?
Yeah.
Y is missing, that means this is a special line, and when you have x equals a number, which in this case is -3, it's a vertical line going through -3. So it's a vertical line going through -3, it's that simple, okay? There's no method, no technique to use, you just have to know. It's a vertical line because y is missing, and whatever that number is, it's going through -3, okay? And when you have when a vertical line, n is undefined. N is undefined, automatic. Is it okay?
Yes.
Right, number 6? Yeah.
For the equation y equals 6, -6x.
Y equals 6, -6x. I want you to graph this.
Answer parts A and B. State A is state that x and y intercepts, and then B is the intercept.
Okay, well, here's the thing, this is not in the intercept method form. This is y equals mx plus b form. But I want to use the intercept method form, are you following me? So I have to change, now, I did not do this on my paper, the reason I didn't is to show you. If you keep it the way it is, it's so much work, look at all the work it is. Cross that out, just put a big X through it.
Ooh, yay.
And I'm gonna show you how to redo it better, okay? You can find a little spot for it, it's not gonna take long, okay? And just to show you that form makes a difference, form makes a difference. They want us to use the intercept method, right? Because they want the intercept. So the intercept method only works when x and y are on the same side. You have to remember. So this x has to be on the same side. In order to use intercept method, move the x term. Move the x term to the other side. So now I get positive 6x plus y equals 6. Everybody agree? Just did a move, one side to the other side. Change the sign in the move. It's called transpose. Everybody clear? Right? Now it becomes super easy. What I had to do there to show you the difference between using the wrong form for the wrong method is a lot of work. Math was not designed to be that much work. That's why I was trying to show you the difference. That's too much work. Now you're going to see how easy this is. This is x comma 0, because this is what they want. This is the information they want. This was the wrong form for it. The wrong form. Get the x on the same side as y in order to get this form, this technique. Okay, we're following? And when you have y is 0, 6x equals 6, what's that? 1. See how easy this is? How long did it take me to do it? It took me like 5 or 6 lines to do it. 2 here. Okay? So this is 1 comma 0. There's the answer to number 2. The first part, this one, who's a 0? X. So y is 6, nothing to do there. Y is just 6. Here are your 2 points. How quick was that? Just by doing one little thing. Just moving one guy. That's all it took to make this piece of cake. By not moving that one guy, it was a monster. See how form is important, how math is designed for you to use the proper form, proper technique. It's like Pearson's telling you, gave you a wrong form, and it's like if a carpenter was trying to fix something with the wrong tool. It's not, yeah, you might be able to get it done, but it's going to be a lot of work to do it. Yeah, a lot more patch-up you have to do if you're not using the proper tool. Once I found out that there's a tool for everything, just get the right tool, the job is so much easier. So much easier. And the same thing with math, the right tool for the right purpose. Everybody all right with how to do this one? We're good? All right, number 5, who's next? I think it's Natalie, I think. It is. All right, number 5. Number 5. I think they're running.
Why are we going
Yes.
backwards?
Find the missing coordinates to complete the order calculation.
Okay.
To be given on the equation 3x minus 4y equals 19.
All right, and then we just give you 2 points and just you're missing, one piece is missing.
Yeah.
Yeah, and you know what, the rest of the questions for E2, 1, they're all the same like that. That's why we can do these, they're all the same. All right, so which one, what point did they want you to fix first?
I believe it is the y.
Yeah, but, okay, so we just show me how they write it. Did you do their number with a comma?
Yeah,
Okay.
they just wrote -3.
Yeah, and then they have a comma, right? Yeah,
sure.
and then they have a blank. So
Yeah,
they're
they have a
telling you which
Okay.
one they're giving. They're giving you X, you gotta find one.
Okay.
And then the next one is probably, they leave this one blank and then they give you the second one.
Yeah.
Yeah, so they're telling you to find X and they're giving
Like,
you,
formatting just makes it look like -3.20.
yeah, so what's the second one?
2.
Just a 2 there like that?
Yeah.
Okay. This is not -1?
No, it's
Oh,
-3.
-3. Okay, fine. All right, so we got -3 comma nothing and then nothing comma 2, correct?
Mhm.
Okay. So on this one, they're telling you X and we have to find Y. On this one, they're telling you Y and you have to find X.
Mhm.
So that's the difference between the two, okay? So on this one, we're gonna plug in, now, when you answer this one, it's gonna be 2 parts. What Pearson wants is they want you to just solve for Y by itself, like just give you the equation for Y, and then they want you to find the number. So part A is they want you to get Y y alone. So they just want an equation with y alone. Y alone equation only, not the answer. And then the second part, they want you to plug in. Plug in -3, and they get y equals a number. So the second part, they want a number, but the first part, they just want the equation. So they want you to change this to be y equals mx plus b. They want you to change the form. This is standard, and they want you to change it to this. So you're gonna have -4y equals -3x plus 19, and then you're gonna divide everything by -4. So you're gonna get y equals 3/4 x minus 19/4. So this is part A. They want you to just get y alone. Okay. I'm not sure of this particular question, but on some of the Pearson questions, they're asking you to solve for y. When they say solve for y, they do not want this answer, they want just the y equation. Okay. And then if they have a part B, if the part B will say, okay, now tell me what the y is for this point, tell me what this y is. So that's just part A, and now for part B. And for part B, I don't care which equation you use, I like this one, I'm gonna use this one, I'm not gonna use that one. So I have 3 times -3 minus 4y equals 19. I'm gonna find the y when x is negative. So now I'm doing this. So I'm plugging in the -3. That's gonna give me -9 minus 4y equals 19. Then I'm gonna transpose that -9, so I gotta get y solved. Okay. So I'm gonna get -4y equals 19 plus 9, because that's a -9, and I move it to plus 9. -4y equals 28. And then you divide by 4, or -4. 28 divided by -4 is -7. So y is equal to -7, so you put in -7. So when x is -3, y is -7. Are you okay with that? Mm-hmm. Alright, and then down here for this one, I have to put the y in, then I'm gonna find the x. And again, I'm not gonna use this, because this one is only good for graphing. I would never use that for anything else, because I don't want fractions. And you're always gonna have fractions with that. So I'm gonna go back to the standard form to do answer all the questions. Alright, so now for this one, I'm gonna plug in the 2 in for, the y, so it's -4 times 2 equals 19, and we solve that. So now I get 3x minus 8 equals 19, 3x equals 19 plus 8, 3x equals to 27, and then if you divide 27 by 3, what is x?
9.
X is 9. So in this one, x is 9. Okay. So for the filling in these points, I use the standards, but I believe they want the equation, so and then the standard. All right, how do you feel about question number 5? All right, question number 5, and then all the others are the same. You want to take a look at question 1, 2, 3, and 4, and tell me which one you'd like me to do that. This is all the same, just plug in and find it. We all right with the other questions? Can you do the other questions all right on your own?
Yes,
1, 2, 3, 4?
yes.
And it's just plug in. So now you can do it. You all right with that?
Uh-huh.
All right, let's put everything away, and we're gonna head over to take our test, your test 1. Do you need to, have me go over anything before we go over it?
Can we just do one question and not do the other?
Yeah, the absolute value, is going to do one question of absolute value, and then we'll head over, okay? Well, what I'd like you to do first is just give me the steps on the absolute value, like just talk me through the problem.
Okay, the first one is gonna be, the first step is put 0 to the prep step.
Yeah, the prep step, and what are you gonna do for the prep step? You're gonna transpose the loose term,
Yes.
and then you're gonna move the bar
Isolate the bars.
by doing a split.
Yes.
And then, okay, so go ahead, do you want me to do a particular problem or the same one that we had on this?
We can do the same one.
Right, so I believe that one was one, I don't know, I can't remember
Yeah.
what,
That's correct.
I don't know, was that it? Or was it 6?
Yeah.
Is that the problem, the original?
Yeah.
Okay. So first prep step, we're gonna transpose any loose. This is called loose, we're gonna transpose. So now I have absolute value 1/6, 5/4x equals 4. So now I've got a result. Now, to remove these bars, you're gonna need the negative and positive of that result, so we're gonna do a split. I want what's inside here, because I'm moving the bars, is gonna come out, and I'm gonna set it equal to a positive of the result, positive. Then I'm gonna take what's inside the bars, and I'm gonna make it a negative. So this is a negative, this is the positive version of what's inside, the positive and the negative version of what's inside, okay? That's called your prep step. First you transpose to get the actual result. This guy has to be alone before you can split it. You can't split him when he still has that +2, it won't work. So he has to be alone before, this number has to be the actual result before I can split it. It can't not be finished, it has to be the actual result. And I won't know the result until this guy's over. Okay, everybody clear on that one?
Yes.
All right, now you're just gonna solve for x like normal. Clear fractions. Simplify, transpose, isolate. Those steps need to be drilled in you.
Yeah.
This is not a denominator, this is a numerator. The denominator is 1. So he's not involved. These are the only two denominators I have. And a 12 would work for this number. So I'm going to put a 12 parentheses times 1 over 6 minus 12 parentheses times 5 over 4 times x equals 12 parentheses 4. That 12
Yeah.
goes across the board. It's to clear fractions. I'm clearing, that's a 2. Clearing, that's a 3. There's nothing to clear there. So now I have 2 times 1 is 2, minus 3 times 5 is 15x equals 48. Then I transpose my 2, that's going to give me a 46. Negative 15x equals 46, because I subtract the 2 from the 48. I divide by negative 15, negative 46 over 15, that's my first step. That's it. These are the 5-step process. That's the split. All right? Now, this one, same thing. I already know it's 12. So 12 times 1 over 6 minus 12 times 5 over 4. 12 times negative 4. So clear. 2 minus 15x equals negative 48. And when I transpose that negative 2, it's going to be negative 50. So subtracting 2 from already a debt. Divide by negative 15. The 2 negatives will go away, and I have 50 over 15, and then the 5 is in both. So it's positive 10. But the gist of it, these are the 5 steps. That should be kind of drilled in you. This is the only thing that's new is the prep. That's new, this should not be new. And the prep is get rid of that loose and then do a split. Are we okay with how to do that for value?
Yes.
All right. I just go over and get the, you go in. We are taking a test, so there's no talking to each other, all right? No cell phones, a calculator if you have one. Or, different. Yeah, and anybody can do homework, you can redo. You should just really give me a good one. Because I'm gonna keep your eyes straight. I'm gonna give everybody 5 additional points.
Thank you again for the 5 points.
Oh, no problem on that one. It's just that I want to see, you see your work, you do your work and you organize, you're less likely to trying to get you to reward you to show your work. That's what I can do.
Right, I took the test Thursday, this is my last attempt at the test, right?
Yeah, there's always
Oh, you have 2 attempts on the test? You have 2 attempts on the test? I didn't know that.
So she's gonna make you put the phone.
Oh, no. Thank you. I appreciate it. Yeah, I gotta go. I'll call y'all back. Bye. Pray for me.